My name is Maia Quicksall, and I'm a rising senior. This summer, I'm conducting research with Dan Grodner's Psycholinguistics Lab. My summer research is examining a topic called scalar implicatures, and it's essentially how people read between the lines when having everyday conversation. Consider a simple statement like, some of the students passed the test. This could be interpreted as two ways. Some could mean possibly all, or it could mean not all. And these obviously have two very different implications. A lot of times when speakers use a very weak statement like some, listeners will interpret that that must mean not all because the stronger alternative of all was not used. This type of inference is a scalar implicature, and it's universal across all of the world's languages. And even though this requires some degree of reasoning and social context, our brains actually do it very automatically. And we're interested in how the mind computes and differentiates between different types of scalar implicatures and comparing that to different meanings, like more literal meanings. There's two prominent theories about how we compute scalar implicatures. The first is the literal first hypothesis, which is that we first derive the literal meaning of a sentence we hear, and then after that, we read between the lines more and can derive the implicature. The other theory is the meaning-dependent hypothesis, which is that actually all of these meanings are available to us instantly, but we then have to select which one we like best by which context makes the most sense in the situation. So we're trying to see which of those theories are more supported. And to explore these questions, we're mostly looking at reaction times as our participants are performing different types of interactive tasks that relate to scalar implicatures. We want to see how long it takes to conduct different types of scalar implicatures and how long it takes to conduct those versus more literal sentences. And then we're also starting to lay the groundwork for eye tracking research so that we can see how participants are computing scalar implicatures in real time as they complete a task. Through this research, I've most enjoyed being able to study a field of psychology that I previously was not very familiar with. And I'd like to thank Panaphil Foundation and Francis Velay for this opportunity.